Hi everyone, welcome to the review video for Chapter 1. We're going to go through about 10 questions and kind of rehash some of the terminology and vocabulary that came from categorizing data and kind of setting up the basic vocabulary that statisticians use to talk about their work. So we're just going to go through some multiple choice questions here and hopefully clarify some of our concepts here. So number 1, identify the population. A survey of 500 adults in the U.S. found that 54% drink coffee daily. So for identifying the population, I like to think about this as like the overarching group that I want to know something about. A sample is a subset of that group that I actually ask or experiment on or do some kind of survey with. This is what I call the sample. It's a subset of the overarching population. Now, why do we take a sample? Well, a lot of times the population that we want to find out something about is too big to take a census, right? If I wanted to find out something about the entire U.S., well, I can't really ask everybody a simple survey question, so at best I can take a sample, and hopefully that sample is representative enough of the population that it's revealing in some way. So that's pretty much the situation that we have here. I want to figure out something about maybe the coffee drinking habits of people in the United States. Well, I can't ask everybody in the United States, so I ask 500 adults. Now, clearly those 500 people are not everybody in the U.S. So in this situation, the population is everybody in the United States, not just those 500 people that I asked. So the answer here, it has to be B, collection of all adults in the U.S. Now, number 2, identify the sample. Same situation. A survey of 500 adults in the U.S. found that 54% drink coffee daily. Well, those 500 people that I asked, that's not everybody in the United States, but it is a sample. It's a fairly decent sized sample. So I would say that that is what's consisting of the sample. Number 3, true or false? In the statement, a survey of 500 adults in the U.S. found that 54% drink coffee daily. 54% is a parameter. Now, I've got a little mnemonic device that I use to remember the difference between a parameter and a statistic. Population and parameter both begin with a P. Population, parameter. Parameters are the numerical values that are describing a population. Sample and statistic both begin with S. Statistics are the numerical values that describe something that's coming out of the sample. These two things are completely different groups. The sample is a subset of the population. It's some of the people in the population, but not everybody. So they're two different groups. Therefore, the numbers coming from those two groups are also going to be different. So in this situation, the 54% is talking about a proportion of people coming from the survey of 500 adults. This 54% is coming from the survey. 54% of those 500 people said that they drink coffee daily. So in this instance, the 54% is a statistic, right? It's not a parameter. It's what's coming from the sample. So in this case, we say false. Number 4, true or false? The costs of items in a shopper's grocery cart represent quantitative data. There are two types of data. There are qualitative and there are quantitative. Qualitative data, another word that statisticians like to use, is categorical. Categorical data. This means that I'm just grouping things using a label, right? So eye color, your major in college, the state that you live in, that's categorical data. It's nothing that I could meaningfully find an average or a standard deviation or do any kind of manipulation as far as numbers. That's qualitative data. Quantitative data basically means that I can assign some kind of number to it and do math with that number, right? Find an average, find the standard deviation, find the variance. That's quantitative data. So costs of items, price, is quantitative data, right? I can find an average price if I have essentially the same item but from two different brands, like, the knockoff brand versus the brand name. I can add those two prices together and divide them in half and see what the average cost is for virtually the same item. So in this case, yes, price represents quantitative data. That is true. Number 5, true or false, the social security numbers of students in a class represent quantitative data. Okay, this question always trips students up because, we think, a social security number. Well, it's a number. It must be quantitative. Well, no, not necessarily, because those numbers are essentially labels, right? It's just like a number on a jersey, like some football player's jersey number. It doesn't make sense to add up all the jersey numbers and divide by the number of people on the team. That average doesn't really mean anything to us. It's the same thing as if I were to take everybody's social security number and add them all together and divide by the number of people in the class. That doesn't really mean anything. A social security number is itself a label. So in this case, this is actually qualitative data. So we're going to say false for number 5. All right, number 6. Identify the data set's level of measurement. Okay, so once we kind of have an idea of whether something is qualitative or quantitative, then we take it a step further and we give it a level of measurement for what we can do with that piece of information. The lowest level of measurement is the nominal level, which just means that we can name stuff. There's really no order to anything. It's basically just a list. At the ordinal level, we're still kind of categorizing things. But in this case, we can put some kind of order to it, but with order. At the interval level, here, differences between items have numerical meaning, meaning that we can actually do a subtraction problem and the difference between them has some kind of intrinsic value to us. And if we take that one step further and introduce what we call an inherent zero, we're at the ratio level. I don't know if I'm spelling this right. Inherent zero. I don't know if I spelled that correctly. That means the zero there literally means nothing, right? So at the interval level, we can think of, like temperature. Temperature is at the interval level. 0 degrees Celsius does not mean that suddenly heat does not exist anymore. The 0 is just a place on the scale. At the ratio level of measurement, 0 literally means nothing. Meaning is nothing. Means it does not exist. So if we're talking about an IQ score, right? Does it have inherent meaning to me to say that there's an IQ of 0? Can anybody really have an IQ of 0 and still be alive? No, not really. 0 in this case just means a place on the scale, right? An IQ of 0 there does not mean that person doesn't exist or doesn't have a brain or something like that. Maybe they're in a coma, I don't know. But 0 in this case does not mean nothing. It's just a place on the scale. So in this instance, we're going to say this is at the interval level of measurement. Right. Number 7, identify again the level of measurement, the nationality of each person on an airplane. Well, there's really no way of calculating a difference between nationalities. What would it mean to say, Chinese minus Russian? That doesn't even make sense. I can't subtract nationalities. So automatically interval and ratio are out of the picture. I can't subtract any two of those items. Now, is there a way to order nationalities? And I'm not just talking about alphabetical order, some kind of numerical order. Well, nationality is a categorical label. So in this case, really the only thing I can do with people's nationalities is just list them out, like record them. I have really no way of ordering them. So in this instance, this is at the nominal level of measurement. Number 8, identify the data set's level of measurement. Salaries of nurses at a hospital. Well, differences between salaries have numerical meaning, right? Some person makes this much money, another person makes this much money, and finding the difference between those two salaries has a meaning of $10,000. So I know I'm already at either the interval or the ratio level. To know the difference between the two, I'm back up at this question. Let me scroll back up here. I'm back up at this question of whether or not there is inherent meaning in the zero, right? So I look at this situation here, salary. Is there inherent meaning in the zero in this case? Well, if I don't work at that hospital, I make $0. Or if I get fired, I'm making $0. So the zero here is not just a place on the scale. It actually has meaning to it. It means nothing. I make a $0 salary at that hospital. So in this case, we are all the way up at the ratio level. Number 9, decide which method of data collection would be most appropriate. So between observational, experiment, simulation, and survey, what would we use to study the effect of using MyStatLab on grades in a statistics course? Okay, well, there's really no way of surveying this kind of information, right? Unless you've used it before, your opinion doesn't really mean anything. I can't simulate it. I need people actually taking the course and using the software. So it's between observation and experiment. So if I could separate my class into control and treatment groups, then I would say that it was an experiment. Well, I could have one class taking and learning the information with traditional methods, and then I could have another stat class using the MyStatLab Pearson product. So one would be the control, traditional methods. The other would be the treatment group using the MyStatLab. So in this case, I'm not just observing the results, but I can make them come about by using treatment and control groups. That makes it an experiment. All right, last question, number 10. Identify the sampling technique used. Students are classified according to major. 20 students are selected from each major and asked how often they use the library. Okay, so if I split everybody into major, here's maybe education and nursing and business and communications and criminal justice, right? So everybody is already classified based on their major of study. Then from each of these groups, I randomly select 20 people. So 20 people are coming out of education. There are more than 20 people in education, but I'm randomly selecting 20 of them. Randomly selecting 20 from nursing. Randomly selecting 20 from business. 20 from communications. 20 from criminal justice. And these people all together become my sample. This is what we call stratified sampling. We're already grouping people together based off of a particular characteristic. And then from each one of those groups, I get a random sample and put them all together to become one big sample. This is so I'm equally representing all of these majors without maybe getting too large of a chunk from any one particular group, right? So this is what we call stratified sampling. I take a little bit from each classified group so that everything is equally represented. I've got a little bit of everybody in my sample. So this concludes our review for chapter number 1. Obviously, I didn't cover every single little detail of that chapter, but these are kind of a little sampling of questions of how things will be worded, the types of concepts you'll have to know for your exam. So hopefully that was a good overview for you, and if you have any questions, please let me know.